Welcome, everyone. I'm going to share my screen here and we'll go ahead and get started. It's great to be here. I'm thankful for Karen for giving me the invitation to come and talk to you all about this new program. So my name is Kim Slack, and I'm an instructor for the new Civil and Construction Engineering Technology program, which is being offered at Portland Community College at the Sylvania campus. And this is a very new program. And so we're just excited to just keep everybody informed about what we're doing. So I have some kind of trivia questions we'll be reviewing about different aspects of civil engineering and construction. And then we'll just give you some little tidbits of information about our program. So I am going to give you a little bit of a disclaimer. I haven't used the polling feature in Zoom as much as I would have liked to, but I'm going to be using that. So if it gets a little clunky, these are just my apologies for that in advance. And so just a quick minute about me. I've got 12 years of experience working as an environmental engineer and a civil engineer on projects throughout Portland, working with drinking water, wastewater, stormwater, making sure that our water infrastructure is keeping us all healthy. And so that's kind of my specific background. And I just, I have some fun experience, but also I'm really also excited to be teaching these days as well. So with that, we are just going to jump right into a question. So look at these pictures, think about what they have in common. And I'm going to actually see about doing a poll. And where is it? I guess I don't have that, but we don't have to, I don't have the poll on my thing. But what we can do instead actually is put in the chat the letter that you think the answer is. What is your answer to what these things have in common? That'll actually be easier to just use the chat. So we've got lots of different things. F, infrastructure. Okay, other thoughts? E and F. Okay, interesting. All right. F and C. Okay. E, C, E, and F. Solutions, community, and infrastructure. Okay. We have here. So we've got a gradation of answers of correct and incorrect. So here, they all have to do with civilization, infrastructure, community, solutions. Triangles is not an answer because you don't see triangles in all of them. But these are all things that make our modern life, our daily life, our civilization safe and comfortable for us. There are things that we don't think about ever, really. I mean, I drive across bridges every day and I don't think about what went into building that bridge. As a civil engineer, I say that the best design is invisible. And when you know about it, that means that there's a problem. When you kind of think about when you're thinking about infrastructure, and we really only notice it when something goes wrong and then there's some sort of crisis at hand, right? So it's really pretty exciting field to be involved in building all of this infrastructure that is just sort of invisible under our noses every day, but you get to be a part of making it happen for a community. Okay, next trivia question. What canal greatly transformed America's transportation network? The Panama Canal, the Erie Canal, the Suez Canal, or the Erie Canal? Okay, we have A, B, and A. Okay.
I didn't even know there was an Erie Canal.
It's just yeah, it was one of the
that's a trick. Yeah, I was like,
the trick.
Where's
I actually did not write this question.
Okay, Hill High, any answers? You guys taking a guess?
A. Okay. So I think this question should be, I don't think A is wrong either, because A has been pretty significant to our transportation in terms of the goods and services that we get, especially over here on the West Coast of the United States. But back when we were a fledgling country, the Erie Canal was a huge technological advance. It really revolutionized how things were transported, and it affected the daily lives of a lot of people in the beginning stages of our country. And this is getting into some history that I'd like to bone up on a little bit more, to remember when was the Panama Canal built versus when the Erie Canal was built. But another really important piece of our infrastructure in our history. Okay, this one I think is pretty interesting. So we have a woman and a bridge. And so what's the connection between this woman and the bridge that's on the right? So is she the person standing on the right in the bridge photo? Is she the mother of the chief engineer of the bridge's construction? Or she was the surrogate chief engineer for the construction of the Brooklyn Bridge? Or she was killed in an accident during the construction of the bridge? Susan is guessing C. Any other guesses? C. All right. C and D. Okay. Well, you folks have done better than my students who I practiced this on yesterday to see how they did with this question. C is correct. So this woman, I'll talk a little bit about her on the next slide, but she was the surrogate chief engineer for the construction of the Brooklyn Bridge. And this is something that I actually only recently learned. I can't believe I didn't learn it when I was going through engineering school years ago. Emily Warren Roebling. I had never heard this particular name, but she is a pretty important person in the history of the field of civil engineering. She was known as the woman who saved the Brooklyn Bridge. She took over her husband's job, who was the chief engineer for this construction project. He died of, or he didn't die, he became bedridden and debilitated by this decompression sickness. When you built bridges back in this time period, they had just developed this new sort of technology of these pressurized chambers that you would go into in order to do the construction of the pier and foundation work of the bridge underwater. And so that experience of the human body going in and out of this pressurized chamber, it gave him this decompression sickness, and it kind of took over his faculties, and he was bedridden and he couldn't do his job anymore. He couldn't even communicate. So his wife, Emily Warren Roebling, took over his job and became the first field engineer. And she just took over this project and made it happen. And she kind of made history in doing so. So really important piece of history about the history of women in engineering. So I thought that was interesting. New data.
That is very cool.
Yes, I am very upset that I didn't learn that until this week or last week.
I am today years old when I learned that.
Indeed, yes. And now you know. So yeah, next time you see the Brooklyn Bridge, just remember that it was brought to you by a woman leading that project. So we are here to learn about this new degree. It's an Associate of Applied Science in Civil and Construction Engineering Technology. We're pretty excited about this new program, 94 college credits, and it will prepare you for working in the field on construction projects, small and large. Just some examples, bridge, roadway, utilities. We're going to go over some of the specifics in these different aspects of the field. You could work on expanding and building new bridges on local rivers. An example could be the expansions of highways. This recent 99 expansion in Dundee, Oregon, could be for site development for commercial and private, so local neighborhoods, expanding the Nike campus, things that are right around your backyard. You know, there's a new child development center, PCC Sylvania. So all of these are examples of construction projects and supporting infrastructure in the public and private sector that you could work on. And all of these jobs are in pretty high demand right now. All right, so just a note about this program. This is a program that's going to prepare you to work in 2 years. It's not an engineering transfer program, although we also have those programs as well at PCC, where you would go and attend PCC for the 2 years in this transfer program and then transfer to a 4-year degree. But this program is getting yourself ready for a job, ready to work in 2 years. And we're very applied, very hands-on, less theoretical preparation and more hands-on applied work. And I guess I should say, if anybody has any questions, I don't know if Karen has a preference for doing those at the end, but I'm happy to answer questions as they occur to you. So feel free to, I don't know, unmute yourself or put it in the chat and we can do it then, because I know for me, sometimes when I'm watching a presentation, I have a question and then I forget it at the end. So feel free to chime in if you have any questions about anything. And I have a little bit more information at the end about how to go about entering the program or learning more or figuring out how to apply that information. I'll have some of that at the end. So, but let's think about surveying, and we have a few questions about surveying. So what do consumer surveys have in common with construction surveys? They are built on a foundation of confidence, as they both start with con. The recipient of the survey receives financial compensation, nothing, or looking carefully and thoroughly at someone or something in order to make decisions and provide an improved solution. Pretty quick with answers here. D, very good. Yes. So surveying and doing consumer surveying, it's somewhat the same concept, but there's a whole field of just being a land surveyor. And we go through quite a lot of that here in our program. Another question. I don't know if anybody's heard of this particular aqueduct and Roman engineering feats, but how did the Romans create the Eupalinean aqueduct that was constructed from both ends through a mountain? Geometry and trigonometry. B, educated guesses. C, angle and distance measurements. D, GPS. A and C, nice. Okay. Any other guesses? A. Okay.
That was my educated guess.
That was your educated guess. A and C, those seem good. So angle and distance measurements. Yeah, surveying is all about measuring angles and distances very precisely. And so this is just a little bit of a window into the history of these, of the surveying technology, the Groma survey instrument. So this is what the Romans developed. And there's quite a lot of really interesting and fascinating information to learn about how the Romans managed to build this particular aqueduct, along with a lot of the other things that they built. So right now, what we use is the total station. This is an instrument that's on a tripod, and it can be pretty darn accurate. And we also use other newer technology, and that's kind of a rapidly evolving field that that we have been having a pretty good time getting all of our students well versed in all of the technology that's coming out to make our work more efficient and accurate in the world of surveying. So surveying is you know, looking carefully and thoroughly at the land. This is in preparation to do construction at a site. And it's important to get all of this information as accurate as possible. So here is just an example of a particular project. This is a development project that has been ongoing. And so it is the information that is what is used by the engineers and the contractors to complete the project. So we learn about all of the different aspects and techniques that are important for land surveying. It's a big part of our program. So you'll be trained in operating survey instruments, and we'll be preparing various survey documents. So these could be used for subdivision plats and exhibits and boundary surveys, doing record drawings. We also use this to incorporate into AutoCAD and Civil 3D software to create drawings. And you also use surveying to create topographic survey maps. And you can do collect this data to support office calculations and to then go out and do construction staking and property documentation. And it's also used to prepare legal descriptions of real property. So it's a pretty extensive portion of our program. Another thing that we do in our surveying department is we're starting to look at the incorporation of using drones. That's something that's becoming really more and more common in the construction industry as well. So we're incorporating drones and GPS features as well. So learning how to wrap all of that together. Okay, another thing that we do a lot of in our program is learning how to be drafting technicians. And so thinking about the role of a drafting technician, thinking about what are the job responsibilities that would apply to a team member that is the civil engineering drafting technician. So verifying the engineer's design with multiple check calculations. Are you translating designs and sketches from the engineers into clear construction plans? Are you verifying the field construction follows from the construction plans? Or are you taking elevation readings of the land to determine the cut and fill required for a project? What would you be doing if you are the drafting technician? B, translate designs and sketches from the engineers into clear construction plans. And B is right. Yes, we're going to talk about the roles that are played for C and D here in a minute, but the important part of computer drafting is that you are creating those plans that are essentially the Bible for any construction project. And it's a really critical part of a construction project. So being able to make those plans in a way that's clear for everybody is really important. And we are be learning how to operate all of this software and tie it in with the rest of the project. So this one's interesting. This is a visual one. Take a look at the drawing on the left and the pictures that are on the right, and which image reflects the black and white AutoCAD drawing here. A, B, C, or D? B. Okay. See how we did here? B. So you can see some of these features and the bolts lining up in the picture here. You can see this side view where you see bolts coming through. These bolts are there. So with time, getting well versed in looking at engineering drawings and being able to translate those. So being able to translate a design idea into construction drawings is the skill that you're going to learn as part of our drafting portion of our curriculum. And so these are just some pictures. This is another set of images related to the historic Euplanian aqueduct design. So this picture here is a picture of that aqueduct. So it's been around for a long time. We've got some more advanced tools in our toolkit to create these drawings to construct bigger and more advanced structures in our built environment. And so we have sort of the latest and greatest programs that are used in the industry that you'll learn how to use to make these construction drawings. So going through these points really quick, CAD and Civil 3D is a really, really important part of civil and construction engineering work. And the level of sophistication of these programs is keeps getting more and more impressive and integrated. And the way that things are happening more electronically as opposed to on paper is a really big way that the industry is changing. And so just making sure that we're using the latest programs that the industry is using and integrating these drawing changes. Often you're making changes as the project is going. And so being able to create up-to-date drawings and be able to communicate all these changes clearly is something that we talk about a lot, and that our students are getting pretty direct and hands-on experience in. So, okay. So we're going to move into talking a little bit about another part of our program that's materials testing. So we probably are all familiar with the Tower of Pisa, but do you know why it's leaning? D and E. So why is this tower not straight up and down? Why is it leaning? We have D and E, I think, as some guesses here. Wind and low capacity of the soil. C, aliens. Okay. For sure, aliens. I mean, you never know. E, low capacity of the soil. Okay, so it's not aliens, the low capacity of the soil. So a really fun part, I have a lot of experience working with dirt and soil. So I think this is one of my favorite parts of the program is materials testing. So it's testing the soil and the ground that you're planning on building on to make sure that you have a solid foundation of your building. And so if you have a soil that is really easily compacted and doesn't have a lot of capacity to have a load put on it, then you're going to have problems like the Leaning Tower of Pisa or other building collapse or slow subsidence problems. And so if you have that type of soil, you just need to know what types of additional engineering design modifications you're going to need to do to that soil to make sure your foundation is going to be stable. And so we do a lot of hands-on labs where we go out and we do testing and we tour gravel and concrete and aggregate facilities to learn about how these foundations and building sites and excavations are prepared to have a safe building site. And so we have a lot of pretty cool materials and equipment to do that testing in our lab. Okay, next materials question. So the Grand Coulee Dam, this is what's pictured on this slide. And it's the largest power station in the United States that produces both hydroelectric power and irrigation water. So what is the primary material that is used to build it? A, steel, B, wood, C, compacted soil and rocks, or D, concrete. We have D, everybody's pretty aligned on D. We have C, compacted soil and rocks. And the answer is C, concrete. So concrete has been a pretty major technological advance in the construction industry. And you'll learn a lot about how to do compaction and shear and compression testing to break the concrete. And that'll give you a data point of how much force it can resist before it fails. And so that's a really pretty fun way to ensure that you have stable and well mixed and well poured concrete. So what about concrete? Can it be made to float? True or false? True. Ohio says false. False. No, it cannot. Actually, yes, it can. So I don't know if you've been through civil engineering school, or if you're familiar with some of the events that the American Society of Civil Engineers does. They have a big tradition of having this contest to build a design and build a concrete canoe. And so this is something that you can do. You can build a canoe out of concrete and take it out for a spin if you would like. But it consists of air, water, cement, aggregates, and coarse aggregates. So if you modify that mix, you can indeed make it float. So now you know that you can make concrete float. I personally didn't do the concrete canoe when I was in school. I did some other, I did more Engineers Without Borders than the ASCE activities, but yes, you can make a concrete canoe if you really want to.
That's pretty interesting.
Yes. Yes, you can if you would like.
Adding that to my new information about Emily Warren Roebling.
Yes. So some of the new things that you're learning today.
Thank you.
You're welcome. Yeah. So, so in the world of materials testing, you can test the different types of strength of hardened concrete cylinders or beams. And you can, after they break, you do a visual evaluation of how those samples or specimens have broken, and that will tell you how you might need to change the concrete mix or the method of pouring if you need to do some testing to verify the ultimate stability and safety of the structure that you are building. So this is a pretty fun part of our program. We have a lot of really cool equipment in our lab that gets students right involved of testing the durability and the compaction and the suitability for construction of all of these materials that we rely on to build our structures. I will mention that just last week, my second-year students were working on our capstone project, and we're doing a feasibility look at some parking access for a potential new urban production farm and community garden at the campus. And so we just did some soil compaction tests for to look at the suitability of some new access facilities for that project. So we are always just directly involved in our work. We do some classroom stuff, but we often get our hands dirty. So another important part of our program is inspection. So these are like building inspections. So we have a series of pictures here of a hotel atrium or lobby, and it has collapsed. In the picture that you look at over on the right, there's been a collapse. And so this as-built, if in the middle, the as-built detail versus the original detail, there's something in there that doesn't match. And so, you know, looking at that, thinking about why that collapse happened. So, you know, why would this, what could have been done to prevent this collapse? Was it care in inspection? Maybe larger bolts, additional columns, or higher design loads? We have Karen with A, or C and D, Emma A, and care and inspection. So looking at this difference here, we see that the as-built does not match what the original detail was. So this is we cover building inspection, and we have field trips, and we where we see this on the ground. And building inspection is a really important part of making sure that what we build is safe. We can go through lots of fairly high profile examples of where there was an error or a discrepancy or some confusion that was made, and where they built something that wasn't correct to code, or they used a material that wasn't specified. And so these this role of the inspector is a pretty critical one to ensure the ultimate safety of our built environment. So we cover a lot of this as well, of how to go through being a building inspector. So here are some more examples of why why building inspecting is so important. So making sure that materials are built as they're intended to. You see that if wood and water and dirt come in contact over a long period of time, it leads to rot. Here we have a sump pump, for example. They need to be isolated in a plastic or a concrete basin. And when it's installed into dirt, things can start to fail. That pump is not really going to operate, and it's not going to work, and you're going to have flooding problems. Here we have a missing pier. That's going to be causing sagging of this floor, so you don't have a good support for the floor of this structure. So we go into some a lot of just applied in the field labs of this, and we've been having some really great field trips of seeing this in action as well. We do a lot of plan reviewing. Okay, so we are all here in the Pacific Northwest. We probably are familiar with the Tacoma Narrows Bridge. Does anybody know? I think it's kind of an interesting video that I'd like to show you because it's pretty fascinating. But does anybody just put in the chat, do you know about the Tacoma Narrows Bridge and why it failed? Yeah. But this was something that the engineers didn't actually know. It's not like there was a mistake or a corner that was cut in the construction of it. It was just a new piece of learning that the engineering community did, and so that's why it's been such a well-known event. If I wanted to show the video, I have to actually maybe I can change my settings. I've realized this over time. I can go into and change it to optimize for video, or do I have to? Nope, I guess I have to stop and reshare. Forgive me. Okay.
Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear. In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you
I hear that, but I can't see it.
Oh.
There's an automobile
Can you see it now?
constantly heaving.
There it is. Sorry. Is that better?
Yes.
Sorry about that.
No
Every time.
roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables
Can
of
you
six
start it over, Kim?
wire strands,
Yes.
each 17 inches thick. Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear. In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now. There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches thick. Back out of the danger zone, all stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river, twisting, turning, curling. The lone motorist is forced to abandon the car. He has but a few minutes in which to save himself. Face to face with fate, his destiny hanging in the balance. Will he heed the last warning or perish with the doomed structure? But he saves himself by seconds. No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
Oh my goodness.
So I
I
had
don't know if I want to drive over
video.
a bridge anymore.
Well, the good news is that was a long time ago, and now we know how to design around the harmonics of the wind shear. So I think that's always a really interesting video to watch. And I actually hadn't seen the full video of the actual collapse of it into the water before I had found this clip. So, but it also gives you an idea of the way that these structures can move, and they have this this harmonic of movement. So yes.
That was impressive.
So yeah, so now
Thank
now we know that the engineering codes have been updated to avoid that particular problem when the wind starts screaming through gorges such as our Columbia River Gorge, Tacoma Gorge. So the Tacoma Narrows, I should say. So so yeah, that's a pretty interesting case that I think everybody has sort of heard of. But yeah, like what do building inspectors do? They read the plans and the specifications that the engineers and the technicians have prepared. They meet with the contractor and they verify that things are being built according to how it was designed, and also is the design up to code as well. If there's field testing of different connections or concrete pours or beams, they are there to verify that those tests are done appropriately and that the results are satisfactory. They summarize their activities to document everything. You'll learn that everything needs to be documented very well on construction jobs. And so, so this is another pretty big part of our program. And this is my particular special place in my heart for it is for water. This is where I've spent a lot of years working and making sure we have clean water. So question for you, where does most of our drinking water come from?
Is this part of part of the slideshow? Because you're not sharing your screen right now.
Oh yeah. And I might actually, I like to be able to see people too. Sorry about that. Me and Zoom. There we go. My students are always having to remind me. Okay, get my windows back in order. Where does our surface water come from? Where does our drinking water come from? Surface, groundwater, oceans, chemical plants, local grocery store. See a lot of these, A's and B's. Very nice. Here we see Portland's water. And I think we have a lot of surface water in Oregon. We're very lucky. Many cities around the country only use groundwater. Portland, in fact, does use groundwater, and there's a lot of groundwater wells probably out in the western part of the city for you folks as well, to use groundwater as a supplementary source for when there is issues with surface water. So we do a lot of work. We have a class that's about water distribution systems. How does that water get from the ground to your tap, or from the Bull Run Reservoir to your tap, or from the Tualatin River to your tap out in Washington County, or the Clackamas River if you're over in Oregon City. So there's a lot that goes into making sure when you have that drink of water that you have right next to you right now, probably, what does it take to get that water to your tap that you don't even think about? Or when you flush your toilet, you just kind of have that service to you. And we learn about all of the work that goes into making that happen for our communities. So we work on that water and what systems. We have a lot of automated computer systems that get the water from point A to point B, and making sure it's stored well and making sure that those storage tanks are doing their job. We have to have pump stations a lot of the time to get the water from low pressure areas to your taps, and making sure that there's enough pressure in your pipes so that you don't end up with the surrounding dirt and other water getting into your pipes. So it's a lot of really important work that happens to get that water safely to your tap. And obviously you don't think about it until you get a boil water notice, or until your water is suddenly smells funny or is brown, because sometimes there is a pump station that went out and you have a lot of turbidity in your water all of a sudden. So we think about that, and we do some great field trips to tour water facilities. And this is kind of a training and preparation for being a water system operator. And so, in the interest of time, we'll go into this because there's another video that I wanted to show and have some time for questions. So water system operators, this program can prepare you for a career in water distribution systems and drinking water system operators as well. Just making sure that all of that equipment is maintained properly and evaluated properly, and making sure that all of the infrastructure is maintained correctly, looking at keeping all of those dams, weirs, pipelines, pump stations, storage tanks. They need to be cleaned and maintained every so often. And also supporting in the construction of new water mains and pipelines, and then supporting with individual service lines as well. So this is a pretty intricate system that is operating on a daily basis, and so it's a pretty interesting job. And we have a lot of partners that we do field trips and activities with in the water sector.
I live out in Tualatin and work here in Hillsborough. And so on my drive in on Roy Rogers Road, they're putting in that whole new water pipeline. And it's been pretty cool watching that project from when it started back in, I think, beginning of last summer, and moving along. And now as I'm driving past it every day, I'm going to be thinking about it in a different frame of mind now.
Yeah, yeah, that would be a great thing to go look at for when I,
Mhm.
teach this class again in the fall, and going to these sites and seeing them, what it takes to put in a water pipeline when you're
Yeah.
installing that. Yeah, yeah, it's a pretty involved system. So,
Hmm.
mhm, yeah. And it's also good to know where your water comes from. I say, well, it comes from the Bull Run, but that's because I'm in Portland. I know that the West Washington County gets their water from other sources as well. So,
Well, and don't we have like a higher number of watershed areas than other places around the country? I heard that somewhere that we have um the the purest water, and that the conservation efforts with all of the different watersheds are aligned together to be on that same page as far as like the sustainability of the
mhm,
sheds.
mhm. Yeah, and we are unique in that we have some great sources of water as opposed to other parts of the country. I know that New York City actually has a very similar water source to, say, the Bull Run. It's a fully protected watershed, and I know that we just are water rich in Oregon. So it's, yes, it rains a lot, but we also have a lot of water, surface water at our disposal. So that's good. So yeah, just general results of becoming a graduate of this program is you can do work that directly enhances the quality of life in your community. You can feel sense of accomplishment in completing construction plans for supporting different types of construction projects. You can be fulfilled when you see families and other folks celebrating in neighborhoods that maybe you helped to construct or make possible. Have that new sense of accomplishment and refreshment when you enjoy the drinking water from your tap or flush the toilet. And so there's just a lot of really great ways to just start getting to work in your own community, wherever it is that you might end up. Another really important thing that I just wanted to bring attention to, and I'll wrap up, is the fact that the annual mean salary is fairly high, considering it's a 2-year associate's degree program. After you take out medical related degrees and air traffic controllers, it's actually the second highest paid non-technical job of the 35 that were looked at in this study. And this data comes from the Bureau of Labor and Statistics. But you can get into a pretty good job through this program, and you'll have fun doing it. It's very hands-on. It's a really fun little program. So I'm really excited to be here to talk about it. I do have, let's see, a short video that I could show just to give a little summary if I have time. I know that we're looking at about 8 more minutes, or should I? I'll hand it over to you, Karen, after I get this video up. Here, 1 second. It's about a minute long, and I will share my screen again here.
I like solving problems and I like building things.
I've always been intrigued by bridges, and actually learning how they're built is pretty awesome.
If you're interested in solving problems and building community, then civil and construction engineering technology is a really good field for you to check out.
You don't have to have a math background. You don't have to have a reading or an English background. You just have to have the drive to learn.
There are so many different aspects of engineering that if you want it, you'll probably find it somehow in the world of engineering.
I'm excited about my future because I feel like this is something that I'm going to be enjoying every day.
You get a lot of sense of pride in your work, and you can be with your family driving down the road and you say, oh, I designed that, we built that, you know. You can come out of here with a 2-year engineering degree and come out and make good money and have a good profession and a career.
You will have job opportunities in a highly marketable degree.
Okay,
That's pretty exciting.
so that's a little fly through of our program. So
Does the program start in the fall? Can you join it at any time? What's that look like
Yeah,
as far
so
as
we-
enrollment?
yeah, we enroll in the fall, and so you would start in the fall of that academic year, and then it kind of goes. The clock starts generally in that fall. Mhm. And our Stedman Bailey is our advisor, and can walk you through the different sorts of timelines, depending on if you already have some college classes that you've completed, kind of, or if you haven't, there's, you know, different entry points, but generally the fall is the starting point for that.